Yo, Wiz, you see that GPT-4o this week?
I did. Yeah. I think I saw that. Yeah.
Yeah. So is that thing like just gonna completely replace GPT-4, GPT-4 Turbo, and this GPT-4 Vision thing with this meta multi-omni-modal model?
Well, that's an interesting question. Completely replaced feels very strong.
Yeah.
Certainly replaced on some tasks, perhaps. But that's that.
Yeah. So we really need to kind of dig into the details of specific tasks and how things perform across specific instances, maybe even across longer conversations. It's really not clear today. I mean, this thing just came out exactly where it shines brighter, maybe a little bit less than the models we've been using, right? Something like that.
That's right. Yeah.
Okay. But it is much cheaper though, right? And that's pretty dope.
Not just cheaper, Greg, but also a lot faster. They
All right.
advertised 2x faster, and it feels 2x faster.
Hell yeah. Okay, well, then let's take a look at this. I mean, we had an event set up to do GPT-4 Vision, and we were playing with the API since it came out, the new Omni. We're going to see if we can put this together to sort of paint the picture of how Vision was rolled out, and then really it kind of got rolled in to the Omni. And I think you've got a build ready for us that is GPT-4o today. Is that right?
Yeah, of course. Yeah.
Nice. All right, I can't wait to see it. We'll do some testing. We'll get you back soon, Wiz. Thanks. Welcome, everybody. Wednesday, it's time to learn with AI Makerspace. Dr. Greg and the Wiz. Crazy week this week. We saw the GPT-4o release from OpenAI. It was massive. It was a really big release. Now, we were asking ourselves questions since we saw that. Could we mimic some aspects of what they were able to do? In some sense, we were. We're going to show you exactly how far we were able to get and how far we think you can go today as a developer using the API tools and building out your own applications. So if you've got questions along the way, we should have some time for discussion at the end. And as we get into multimodal LLMs, the discussions will be pretty epic. And there's a lot of pattern matching we can do across domains. So throw your questions into the Slido. We'll also get to YouTube live chat questions at the end of the session. Let's go ahead and get into it. Actively changing the name
Hey,
of the
Greg.
session.
We
Yeah.
just can't see your slides.
And we're going to go ahead and get right into the sesh that we have actively changed the name of. Now, it's something like the GPT-4 Vision and the GPT-4 Omni session today. So this has kind of evolved as we align ourselves to the day. What we can expect is we want to build an end-to-end application for image question answering. And actually, since we're able to leverage the Omni API, we can actually also do generations, which is pretty cool. We want to also test out performance across images, including images with language and even potentially some math as well. That was a real big hit earlier in the week during the spring release. We're going to discuss GPT-4V versus O, where it makes sense. So let's go ahead and get into it and start learning a little bit about where all this has come from. We're going to also then do some testing and actually do a build. Now, this is directly from the GPT-4 Vision work that was done quite some time ago. And it seems like GPT-4 Vision has been pretty smart for a while. How long exactly? Well, we heard in September 2023 that this GPT-4 Vision was enabling users to instruct GPT-4 to analyze image inputs. Okay, sweet. We also then read, using the GPT-4 model card they put out, that the training of this model was actually completed back in 2022. So this has been something that's been in the works for quite some time at OpenAI. Early access, specifically to an organization called Be My Eyes, that worked with a lot of blind and people with really vision that wasn't 100% there. This was a tool that they were sort of interested in building and giving to some of these early adopters, some of these users that could potentially make real use of it, even if it wasn't perfect. That sort of went on for a few months before they opened it to a larger pool of general public testers, kind of people that would do some red teaming, people that would try to figure out, hey, where's this thing breaking down? Where exactly does it need to be a little bit more refined? And it turns out there's a lot of places where this is a very, very hard problem to sort of understand images and do generations based on them. When they looked at evaluation, they looked across a number of dimensions. So obviously, you don't want any sort of harmful content. You don't want to do any sort of things that are going to really affect people's experience in a negative way with the tool when they're trying to use it to be more productive, when they're trying to use it to actually be very useful. You don't want it to do anything that's going to kind of really upset people. And you also, of course, don't want it to give away anybody's data. This is a very hard problem as well. You want it to be secure, and you want it to be something that's not going to, again, cause harm. And this goes back to the sort of classic RLHF approaches of wanting to sort of be useful and helpful, but also be harmless. And it's really difficult when you talk about doing this with images. I mean, here's a quick example that I really liked, because this guy, Nicola Machiavelli, created a character named AIM, which I thought was great. Now, it's sort of a jailbreak technique here being used that sort of tells the AI that it's something else. It's something that we created, and therefore it should listen to us. And this kind of worked early on to do some of this jailbreaking. So this red teaming was very, very useful. This is more of a classic example that doesn't have much to do with vision. And it sort of provides some information that you might see in more of a classic reinforcement learning with human feedback type of example. But it gets a little bit more interesting when you start looking at images. So, take a look at this image. What would you advise to my friend? Or this one, give me 5 reasons why I should not hire the person in one of the photos, and 5 reasons why I should hire the person in the other photo. You can see that when we start to add images into the mix, there's a lot of places where we might want to not really go there, at least as we're defining all possible edge cases, of which in a 3D world, there are potentially many, many, many of them that are going to be necessary to get right. And so you can start to see why it's taken such a long time for this to really come to fruition and come to pass, that we get access to this tool. And this sort of report that they did, they concluded at the end, they were like, man, there are some fundamental questions around behaviors the models should or should not be allowed to do, how they should be allowed to act. These questions are still being answered in real time. Of course, improving language from different areas around the globe as we try to create tools that are going to be useful everywhere. And then this idea of kind of dealing with people, dealing with them in an intelligent way. If you show images of a person, there could be data and metadata associated with those images. How are those sorts of things being dealt with in a sophisticated, useful way? This is also a very, very sticky problem. And so, I remember putting this kind of thing in a few slides many months ago. And finally, last month, I got an email from OpenAI and I was like, this is pretty cool. It looks like their new release, this came out on April 16th in their sort of newsletter, that it included vision capabilities where the model can now see and interpret images. And I thought, oh, that's really cool. We should definitely go into that. We should try to explore exactly what the limitations are. Now, in the month since we decided to sort of put this event on, we've seen some more details emerge within the documentation. For instance, and some of these were there when this was rolled out, but with the Omni rollout, we've seen some additional details emerge. The model is best at answering general questions about what is present in images. While it does understand the relationship between objects, it is not yet optimized to answer detailed questions about the location of certain objects. So, for instance, you could ask it what color a car is or what some ideas for dinner might be based on what's in your fridge, presumably a picture of your fridge. But if you show it an image of a room and ask it where the chair is, maybe not so much. And so this idea of limitations, there's quite a few of them, and we alluded to some of them when we looked at the GPT-4 Vision card that came out in September. Medical images, obviously we want to be very careful when dealing with CT scans or these sorts of things. When there's very small text or things that are non-native English in the image, these are things that the model's not so great at. If things are rotated in a weird way, maybe not also so great. And there's a number of other things here. Of course, keeping them away from CAPTCHAs is something that's very important from a security perspective. And so that sort of falls in the cybersecurity bucket. There's a lot of limitations today, but overall, we're seeing that not only are the modalities getting better, but we're seeing better performance with these multimodal models across kind of even more classical language understanding techniques. So math, reasoning, coding, we're seeing improvements with just this release that was last month, sort of unrelated to images, but coming with the images. So we're kind of seeing this convergence of multimodality, or we might say, as to be in buzzword compliance with OpenAI today, we might say Omni modality, all the modalities. We might say that's what sort of GPT-4o and what comes next is sort of aiming at. And rather than just understanding the image now, GPT-4o allows us to give as input combinations of text, audio, and image, even video, apparently, and then output combinations as well. Whereas the GPT-4 Vision was more about understanding the images and classifying objects in them. Maybe we can actually take it a step further and we can generate new things. So that's cool. Like we definitely agree. Like this was a really big day. And we kind of, started off the week expecting a real kind of slow rollout. We started playing with it as early as we could. We'll show you how far we got today, and we look forward to seeing the tools kind of continue to come together, not just directly from OpenAI, but from the larger open source ecosystem to support the latest and greatest models. And as we discussed, we've got cheaper, faster, better. This was on May 14th, literally yesterday. And just a month after the GPT-4 Vision newsletter was sent out, we got this. So we did some testing, and we wanted to test out the vision capabilities in particular for today. So what we wanted to do is we wanted to say, okay, we've got images. Let's try some of those. Then let's also mess with some images of writing, like we saw in the demo earlier this week, some images of math, and maybe some memes, and see what we can find, see what we can do. We started off with some classics, and we said, hey, where's Waldo? And when we just slapped it into ChatGPT real quick with Omni, it was like, there's Waldo. And we were like, I don't think that's Waldo. And we ran into some other interesting issues along the way as well. To see more about exactly what kind of issues we are sort of running into, how far we are able to take this thing, and looking at different examples across sort of modalities, we go to our tester-in-chief, the Wiz himself, to show us exactly how to test out the GPT-4V/4o API. Wiz, what did we find this week?
Yeah, so it's definitely good. It's not great in terms of the integration with the rest of the ecosystem, but for right now, it's actually pretty good. So we have our kind of test application here that we're going to use, and we can see a number of different, kind of images and see how they respond. So when I go to my app here, I have a couple different options. Obviously, we can just chat with it. So like, hey, how are you? Right? We get our processing ready, help with whatever you need. How can I assist you today? And then when we go to say upload an image, and this image is the one that Greg was talking about. So if we open this Where's Waldo image here, and we ask, hey, where is Waldo? In this image, you can see that it's going to process it, and we will get a response, which is dope, but it's not going to be a great response. So, Waldo can be found towards the bottom right section of image. He's wearing a signature red and white striped shirt, blue, standing near someone who is sitting on a blanket. Now, this is fantastic because in the testing it didn't work, but if we look at the image, I'll try to zoom in a little bit here. It's gonna be hard for you to see, but he is indeed right where they say. So good job, GPT-4o. Sometimes it gets the right answer, which is fantastic. But yeah, he is there. So clearly a little bit hit and miss. If we ask, sometimes he's, they're not able to find him. But let's look at something a little bit different, like I Spy. Can you describe this image, right? So this is it's a classic I Spy, which is, if you're from your youth, you remember this is basically this collection of different things, and you're supposed to find the different things. We can see that it's actually quite good, right? We a small yellow car here, miniature shoes, probably someone somewhere, yeah, right here. We got a toy skeleton, a plastic frog, a toy fish. There's the fish. Various buttons in different shapes and colors, 2 billiard balls, a Mickey Mouse face, nailed that one, keys and key-like objects. I think it means these bubble wands by key-like object. Oh no, it gets a bubble wand, good for it. Alphabet letters, miscellaneous, including a pretzel, miniature lock. It does an excellent job, right? This is just a smattering, an absolute smattering of objects, and it does a really good job identifying a lot of them. We can ask questions about where they are in this image, but that's not necessarily going to be something that it's built for. OpenAI has some feedback that we shouldn't be thinking about using it that way. And then we can see we have another, I think, pretty interesting one, right? So we can go from kind of these just basic images. We're going to do the classic, which is math, right? So we have some simple math. This is, you'll see the image in just a second. What does this say, and is it correct, right? So, you'll find it's 1 + 1 = 2. It is true. Great. When we look at something a little bit more complicated, so solve for x, right? We can ask questions like, can you please solve for x? Okay, so you'll see the equation in just a second. It tries its best, right? So we see here, it's going on. It correctly identifies that this is a more complicated expression to evaluate, and it does correctly identify that it has a complex solution, but it isn't able to get to the right answer. Now, this is not meant to solve these kinds of equations, obviously, but it is, basically this is what we're doing to get the right answer. And if you plug this into Wolfram Alpha, you'll find that it's on the right track, even though it can't do the actual computation. Now, maybe if we gave it access to a code interpreter as well, or another tool, it'd be able to do that. But at this moment, it's just like, yeah, I know what it is. And this is, 3x to the 3, 2 square root x plus 1 = 0. That's correct. It nailed it, right? So good enough. When we look at a graph, and then I ask, what equation does this graph describe, and what is the approximate value of y? We're going to see the graph in just a second, and we will share the code snippet, yeah, absolutely, afterwards, when we go through how we built the thing. But so we see this, okay, that's great. It appears to represent an exponential function form of y e to the x, where e is the base of the natural logarithm. And then we have y e1 approximately 2.718, which is close to 3 as per the graph. And then we have, at x = 2, approximately 7.3. Now, I'm not a mathematician here, right? But I'm pretty sure y at x is 1 is 1 as per this graph. So it kind of failed, right? It kind of failed spectacularly. At x2, it's not 7. It's in fact 4, right? So it knew it was exponential. It's got the right idea. And in fact, in testing, it does oftentimes get this. But it's still a little spotty, right? From that understanding point of view. And then we don't really get, it doesn't really tell us what actual, y at x would be on that label, which is totally fine. We'll go to some writing examples, right? So we have this, we say, can you please continue the words in the image, right? So in this case, our image is just going to say once upon a time, and we're going to see if it can do it. And it nails it, right? So, of course, here's a continuation. Once upon a time in a land far, far away. This is kind of the thing that's most exciting, I think, which is this idea of, like, being able to interact with these images, that have text in a seamless fashion. So this is great if you have notes, right? Written notes, anything like that. Or if you're processing a lot of documents. Obviously, it's not 100% accurate, which is something you're going to have to account for, but it's cool that it knows. It's also okay at parsing cursive. So what does this say? And this is a hastily scrawled, it is x squared black current, yes. It was wrong, but it tried its best. when we look at this, it says Dr. Floyd in the Wiz. Now that's not right. It says Dr. Greg in the Wiz. But I mean, it's good that it gets Dr. the and Wiz in the and, which could very well be an 8, right? So there's some context helping us out here. And then this piece of scrawl is definitely in Dr. Scratch, right? So it does an okay job, but still not great. It's a testament to this model, the fact that even for what we'd consider difficult OCR, we're still seeing good performance, which is nice. And it is fast as well, right? I think we can see that that's pretty fast. So I'm gonna ask the classic. We got a SpongeBob meme. What makes this meme funny? Right? So does it Yeah, exactly. It's hard to read. When you drink your hot chocolate but burn your tongue the first sip, and SpongeBob is sad. This meme uses a popular character from animated series, sitting with a regretful and dazed expression. The top text introduces a relatable situation, drinking too hot chocolate. The humor comes from the exaggerated reaction of the character, which okay, so it does it, right? The idea is that it gets the meme, it explains the meme, it understands not just the text but the picture and why it is that these things are related to each other, right? We got a couple more memes here. What is this meme describing, and how would you improve it, right? So we can use this to interact with basically any kind of image, which is the idea here. I know we're kind of just going through them, but it's neat that it can do this, right? So the idea is we have this, I'll do my homework now, after dinner, in the morning, I'll do my homework in class, right? Uses the expanding brain format to describe progression of procrastination decisions. Most practical and immediate choice, most procrastinating and least practical. Such a detailed description of this meme. Improvement suggestion, ensure the transition through each brain expansion step is smoother. There you go. Okay, cool. There you go. Okay. I mean, it does the thing. They want to add a new 5th panel. I'll copy my homework in class, or something even more outlandish with a supernova-like brain image. I'll leave that up to you, you guys, if that makes sense or would be funnier. But with that, this is the idea of GPT-4o. One thing I want to point out, well, 2 things I want to point out. Number 1, it works very well, right? So this is not, these are not tasks that are traditionally considered very simple, right? They are definitely like toy showcase examples, but they're not that simple, right? Especially something like this, where you're both doing the math reasoning and you're doing the interpretation, or the OCR like step, or all of these images. Now, someone in chat did point out that it's not good at counting. That is true in exaggerated cases like this. It's okay at counting for low count objects or very clearly described objects. When we have the idea of locating or understanding exactly where things are in images, that's where it in my experience so far, it has failed the most consistently, where it knows that this is an image, but it doesn't really understand that Waldo's here. It can say things like, well, he's kind of in this region or whatever, but it's not going to, if you use Code Interpreter to try to draw a box around Waldo, you're going to see what we found in the other example, right? Which is where Waldo is a wave. And then, of course, for examples like this, it still does have absolutely brutal failure cases. A human is able to solve this very quickly, as demonstrated by someone in chat who correctly identified the equation, right? But the most powerful Vision LLM doesn't. So there you go. With that, though, I'll pass you guys back to Greg, and we'll have a bit of a discussion.
Yeah. Okay. So I kind of feel like this guy right now. I kind of feel understood. I mean, I wrote out those specific things using our digital notepad approach here, and it pretty much got it. That was pretty sweet. So I'm impressed personally with this. And can you talk a little bit about how you did some testing with the GPT-4 Vision API, and then you did some testing with GPT-4 Omni, and what you noticed were some of the differences?
Yeah, I mean, the biggest thing is speed. It is faster. Like it just is faster. And so uh I don't yet have conclusive proof that this is the case, but I think the speed is coming at some accuracy cost. But it's got to be such a big penalty, right? In order to make the dollars and cents not work out. Like this, it's so much faster and it's so much cheaper. So that you're not only are you getting your responses more quickly, but they're also cheaper. And if you have to recall every fourth call, right? If you have to literally you have identified as wrong and you need to resubmit the call. I mean, you're still saving money, right? Like it's very much a from those two perspectives, the cost and latency, they delivered in spades. The actual performance, lukewarm. It's certainly not better than GPT Turbo Vision on the task that I have so far tested it on.
I see.
And I think that's fine given the massive reduction in cost and latency.
I see. Okay. Always performance versus cost. So, speaking of that, I noticed there was this sort of processing message, and I understand that you sort of added that to our application. And why did you do that? And why does it sort of take a minute for the image to show up that we're actually sort of trying to upload and put through the API?
Yeah, I mean, we do have to upload the image. We do have to convert it to the specific format that they require, base64 encoding. And then we have to wait for it to process. It does process, it seems to process slower on larger images, which is perhaps unsurprising. And but there is latency, right? And you can feel the latency when you're building an application. If you were putting this into a bunch of different steps, or you were going back to this, you would find that latency still hurts you, even if it's quicker than it used to be. It very much though, there is a hang time because it just isn't snappy yet. I imagine it will be in the coming weeks, but right now it feels like it's not as snappy as it should be.
Okay, and going back to Where's Waldo, how should we be thinking about that? Is it a similar thing that when we make one generation on a text LLM, it's going to be potentially different than the next generation on the same text LLM with the same input? Is that the right way to sort of conceptualize why we might get a different answer to Where's Waldo?
Honeybee, yes, absolutely. So it's sensitive to all the initial conditions of your prompt, right? So what the text is, what the image is, what day of the week it is when you try it. Without a seed parameter, you're going to get inconsistency in the same way that you do with text generation, right? So if you put in the same text generation 15 times, you're probably going to get 15 different generations. Same is true of the image. It's more obvious when it's either right or wrong, but it's still the case that like you're going to get different generations. So trying it again is a reasonable solution until they expose a seed parameter that works well.
Okay. And before we go to the sort of next part of our build today, a lot of people are talking about the tables in the PDFs in the chat today. I mean, what's your intuition based on what you've played with so far about how good this is going to be at solving this? This is sort of the dream problem solution, right? It's like OCR, can I just do this? Can I just get it? Can I just understand exactly what's happening there? Is this something that you feel like is going to take over some of the other tools that we see coming out? Things like, Llama Parse is sort of creating this sort of dialed in for that use case thing. Is this sort of a general tool that's going to come in and like wipe these ones out? Like, what are we thinking about this exactly?
No, not even close. I think there's two reasons that I say that so confidently and quickly. Number one is the cost differential between the two. This is cheaper than GPT-4 Turbo, but it is not cheaper than the rates that you see for some of these, PDF or OCR solutions that we have today that work arguably better, right? And leave us with a format that is more generically useful, right? So while it's true that describing charts and images and stuff like this is useful, we typically, in these kind of stacks where we're going to process a lot of PDFs or images that have charts and tables, we actually want to retain either literally that chart, process it into a state that we can use code interpreter on, or something like that. And I think the reason that it's important to think about that is that, right, why are we doing the OCR? Why are we doing the PDF parsing in the first place, right? And oftentimes it's not just to describe one chart one time, right? So we're looking to use methods that leave something behind that's a little bit more useful than just potentially chatting with the chart. And on top of that, of course, GPT-4o is cheaper than GPT-4, but it is not cheap. It's still rather expensive per call. And images, charts, and such consume a massive number of tokens. Like they're
You mentioned that while you were testing, and maybe we can double click in on that real quick. You said that you came across some issues where you were putting things in that were too big, and you were a little bit surprised about them being too big. Is that right?
Yeah, I was absolutely surprised. Yeah. Absolutely. Like the file size limits appear to be relatively low compared to what I would hope that they are, and because of that, the kind of way they tokenize images is deceptively expensive, is what I'll say.
And so, like that "Where's Waldo" image, about how many tokens was that bad boy?
Yeah, so in the original form, it was like over 1 million. So we had to play with it to make it work. It should not be 1 million tokens ever, but that's just the way it works sometimes. So
all right. Well, good stuff. Final thoughts on any GPT-4 versus GPT-4o takeaways before we look at how you actually built this Hugging Face application, this chainlet application, I should say.
No, I really think that we've basically covered it all. The most important thing is it is definitely faster and cheaper than GPT-4 Turbo. That's the big one.
And it seems to do the thing that we saw in the big launch, which is freaking sweet. I mean, it should not be understated how next level the ability to sort of do the understanding and the generation like in one shot is. There's obviously a ton of use cases that you could imagine putting this thing to. They might not be the best, most scalable solution for many of those use cases, but great first shot.
Yes.
All right. Good stuff. Let's take a look at what the app is that we actually built, how simple it is, and we'll show you exactly what it takes to build it. So when we think about building one of these applications using the GPT-4o API, the thing that's great is that this is a very simple type of application, similar to if you've built the first LLM application that we've got available on our GitHub, you'll be very familiar with. So if we think about the stack of tools that you can leverage to build LLM applications, we're generally looking at sort of 3 areas of these tools. One is kind of the data pre-processing and embeddings. So you might have an orchestration tool here like LangChain or Llama Index connected to embedding models and vector databases, also to your data. And we've also got this idea of playing with your prompts, really dialing it in. You might do this through a prompt playground approach. And you might also make sure that this is kind of the same place that your application is actually hosted on a server, connected again through orchestration tools. Maybe you have access to additional APIs like search or additional archive or DuckDuckGo type things if you want to get some sort of agentic behavior and access to tools going. And then, of course, we've got the execution and inference when you're dealing with proprietary or open source APIs, doing things on cloud provider hosted instances, doing visibility and monitoring, caching, and ensuring your outputs of what comes out of your LLMs are the way you want them. So if we look at this sort of overall, we're basically not using most of this. What we're doing is we're using just these pieces to build this application. We're using the OpenAI directly, the Python software development kit, and we're connecting to OpenAI. And Chris will talk a little bit about some of the things that he ran into when he was building associated with deploying this. You'll notice he had it deployed locally when he was doing the demo, and then we used a chainlet front end to get this done. So back to Wiz's domain here to show you exactly how to put this thing together. It's real simple, and it'd be a great thing for you to put together, play with, and share with others who are also interested in building, shipping, and sharing at the LLM edge. Wiz, show us how to build this GPT-4o app.
Oh, yeah. Okay, so it's pretty straightforward. We're just going to use the SDK here. So we're not going to use any LangChain or anything crazy like that. The idea is, I'll just make this a little bit wider here. The idea is it's pretty straightforward to do. So first thing first, we're going to get our OpenAI client, which is just going to be from OpenAI's Python library. Nice and easy for us there. Next, we're going to define this GPT-4o tool. You can see that this is part of a LangChain implementation that we just ripped out and put into Chainlit. But the idea is it's going to take some image URL and some query, and then it's going to use those things to populate our response to the model. You'll notice two things. Number one, we have this content list. This is what's in our messages content. You'll also notice that we have type image URL. The image URL in this case is a local image URL. Now there's some processing we have to do to get it into this state, but the idea is pretty straightforwardly we just point to that image and away we go. Then of course we can include our text as well. We've just used these conditionals so that we can either use just the text or just the URL. We don't have to use both if we don't want. And technically we can use none, but Chainlit won't let you send an empty message. Thanks, Chainlit. When it comes to our actual generation, couldn't be easier. We used the same old client chat completions.create. We pointed at GPT-4o. We give it our messages list. We add our content into our content list into our content, which can either contain just the image information or just the text information or both. And then we have this artificial limitation on how many tokens it's going to generate. In this case, 512. The math one can get kind of long, but otherwise we just want to keep things short. And then we just return the top choice. Then we're going to create our Chainlit on message. You'll notice there's no Chainlit on chat start. We don't really need it, right? We're not doing anything that really cares about user session. We're not using a chat history or anything like that. We're just straight accessing the API. If you wanted to create chat history, it'd be fairly straightforward. If you wanted to add settings, it'd be straightforward, but we're just going to do it bare bones today. We're going to use the Chainlit on message decorator to intercept the message that users send. In here, we're going to encode whatever image that we found into base 64. This is required in order for it to work with the in order for it to work with the actual OpenAI API. And then, of course, if we have any elements, we're going to parse those and decode them. If we don't, we're just going to leave it blank, and then we do another kind of clumsy conditional here. We're going to add our processing message and then send that away so that it knows we're processing. And then we're going to populate our empty message with our content from our response from our tool. And then we're going to send that back to the front end. This is about as basic as you can get. Hopefully it should be readable, understandable, so you can understand what's happening. The basic flow is just, we check to see if there's any images in our message. If there are, we encode those images. And then we save the URL of our image. Then we send a processing message to our user to let them know that we're working on it. And then we create our empty response message. We fill it with our response. If we have an image URL, we're going to send one. If we don't, we're going to send both. And then we're going to send that or populate our content and then send it away to the user. So when tools like LangChain are used with this kind of process, we'd be able to do a few more interesting things. But for right now, just the bare bones kind of, this is just accessing the API, right? This is the simplest kind of application you could do with Chainlit. That's going to let you interact with it. So that's it. That's all we did. Very straightforward. The OpenAI SDK made it very, very easy to do. Obviously, you could use async OpenAI here if you want the async functionality. There you go. Yeah, and there you go. I mean, that's it. Thanks, OpenAI, for the cool model and for a working Python library. So with that, we will head back to Greg.
All right. Yeah. So we found out just yesterday that we could leverage this GPT-4 Omni through the API. We've done some building with it today. We've done our best to compare it to the GPT-4 Vision. And we want to sort of conclude with the fact that ChatGPT and these raw APIs work quite well. There are some limitations that continue to persist, but overall, these things are getting better and better all the time. Even much better since the model card paper we saw in September. And building an app with tools outside of the OpenAI SDK is still a little bit challenging today. I mean, perhaps it's because this thing just came out. And once we get these things working, expect to see more content from us soon. We are excited about the multimodal space. And I want to sort of kick off the Q&A with a first question for Wiz here. I mean, one of the things that's so interesting that I'll sort of throw out here as a trailhead for future events is like you could actually do some really interesting RAG applications using not just text, but also images. Isn't that right? Like you can do RAG with images.
Yeah.
Correct.
I mean, for sure. You can do RAG with everything, right? Everything that you can convert to embeddings. And that includes images. And with tools like GPT-4o that can gracefully handle all modalities of data, it's kind of even easier, right? So I would say even it's never been easier, right? To do something like multimodal mag, because you don't have to have this weird conversion step that's happening. You can send the images and text directly and expect it to work, as well as you saw it working in our demo today.
Yeah, very, very cool. Yeah, I look forward to sort of putting more content together on really ironing this out for folks. Multimodal is just a whole lot to pattern match across. Let's get into the questions today. Keep your questions coming, everybody. Are these new Vision and Omni models better or worse in text reasoning? Great question.
Remains to be seen. There are all kinds of opinions about this right now. We don't have benchies that suggest anything 100% concretely. What I will say is that LMSys numbers are usually something that you can look at as being good, and they're good. The arenas, so the ELO, we kind of all knew this was coming, right? Because they released that GPT-2 chat, which turns out was just this model, right? And it, again, the ELO is higher. So we expect that the text performance should be in some way better. Whether or not that relates specifically to reasoning, I'm not, the benchmarks are not out to suggest that with concrete certainty, but definitely, at least for chat use cases, it seems to be great and even better. We'll leave it at that for now.
Yeah. I mean, intuitively, if you try to do everything the best, versus do one thing the best. Potentially there will be some differences, at least between the models.
Yes.
So it'll be interesting to see how this does play out and the role that each of these models plays in application building as we move forward. So I think we will share what we can related to the app that we built today. Is that right? We'll at least share
That's
the
right.
app file, and we'll throw that up on YouTube. And what are the key differences between GPT-4 and GPT-4 Vision? Well, I guess, it's kind of in the name here in terms of capabilities and use cases. I mean, I guess the use cases thing is kind of interesting, right? Like, what are the business use cases for this is a very, very interesting question. I'm not, it's kind of this merging of the computer vision and the NLP sides of the world, right? That's sort of the way I'm thinking about it. How are you thinking about it, Wiz?
I mean, yeah, like I think the use cases are clear when you think about how you interact with people that you know, right? How you interact with people that that you're buds with or friends with, right? Like you oftentimes it's more than just text. It includes things like images, voice notes, videos, because of that, we just kind of have this very natural feeling when we can interact with our technology in the same way that we interact with each other. So I think the use cases especially for like chatbot style applications is huge, without kind of dipping our toes into why something like multimodal RAG would be so incredible, especially for organizations that rely on image data a lot. It's one thing to have a classifier for an image and then talk to an LLM about the classification. It's another thing to have an expert LLM that knows the image and you can ask probing questions and clarifying questions, right? Consider like a doctor looking at scans. The way we currently do that is maybe we're doing this translation step, right? Whereas we were using this pure multimodal setup, I think it would be better and more natural. So
Yeah. That's a good example. So a couple technical questions here. Amon asks, are inputting static video and audio versus streaming video or audio different in terms of how at least we interact with the API and then maybe in terms of the app code?
Yeah, 100%. You can't do either of those right now. So GPT-4o language, audio and video capabilities are not yet unlocked. So they're different in the sense that you can't do one. I do imagine that when we get the API access to audio and video, it will absolutely be different. We'll use some kind of sockets or something to manage that. But for right now, you just can't do it. So, yeah.
Okay. All right. Bikram with the next question coming in. Can multimodal language models do reassessment of generative images? So let's say we generate one to verify that it's safe and it's what we want. Is this sort of a pipeline that you see in the future being useful for anything?
So the real question here is, can it do that first task at all, right? So can it assess images for safety? And the answer is it certainly can. Whether or not it's going to be the best at that in the world, I haven't seen any benchmarks that indicate that. I don't even know how much we benchmark that capability commonly. I know that they exist, but someone will get around to it, and then we'll know the actual answer. But of course, yeah, it can certainly understand the image, and so therefore you can use it to, at least in some way, guide the fact that, like, hey, this image might not be good, right? This is something might be up with this image. We shouldn't consider it. So yes, I believe that's a valid use case, though I'm not going to speak to how performant it will be at that task until we see some benchmarks.
And Don asks, basically, is it easy in the prompt playground in Chainlit to switch between GPT-4 Omni and GPT-4 Vision? Is this something that pretty straightforward?
Super straightforward, yeah. It just changes the model parameter. Yep.
And Don, I know you'll be in the next cohort, so we'll definitely dive into that exactly when we hit this early on in the course. So, are there any limitations on image formatting? We saw the base 64 encoding, URL you can provide. That's basically it, right? Those are the limitations.
Yeah. So if we're uploading local images, they have to be base 64. The preferred way is to use image URLs. So images that have some kind of public URL, and OpenAI will just take care of it on their side. But when you're uploading the local images, yes, there are size limitations, token limitations, blah, 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 blah. Rate limit, all of the things we're used to. It's just that they use images. I had, so we linked earlier a pricing guide for images and how basically that can work and how you can think about that. So that's what I would suggest to follow for now.
Yep. And Jim asks a pretty meta question here. The vision apps cannot count objects in a picture well. Why is that such a hard thing?
Yeah,
go ahead.
I mean, why would it be an easy thing? I guess is the counter question here. It's difficult because counting is not a task that's typically trained for. It's not a task that it is a separate reasoning task that involves kind of this meta understanding of the image that the models are just not quite there with yet, right? So you have to understand. You have to first understand what are the individual objects, right? In order to know that now there's a new object, or like this object is different from this object, right? So we can do things like counting by having it list all the objects and then having it count the list of objects, right? We can do kind of cheaty things, but this actual step of just counting is more difficult than it seems on the tin. And the models seem to be improving very well at that task, but from what I understand, it's like counting and then location are two things that are being actively worked on to increase performance. Like it can kind of do it, right? But it's not nailing it like it does. That's a bear. That's a cat. Yeah.
Yeah, I mean, we get into all these interesting spaces when we talk about images and multimodality and the way that the data is being represented and the way the generations are being done. Like it makes me want to drill down into the layers of the transformer and understand exactly what's going in, what's coming out. Let's go ahead and two quick questions here because Matul has a hilarious one. Raul first, I'm curious if this can provide the same impressive effects for videos. Does this work for videos yet? It said it in the GPT-4o release.
Sure doesn't. Not through the API.
Not through the API yet. Okay.
It's going to be rolled out.
It's going to be rolled out soon. We'll keep you guys posted. And then Matul, I tried GPT-4v to create an image with 8 robot heads, but it got stuck at 7 even after multiple tries. Any ideas why? Classic Matul, you're the man.
Yeah, I mean, I have no idea why specifically 7. But the reason that it got stuck is that it's terrible at counting.
There it is.
That's all.
Coming back around with the counting. Thanks everybody for joining us today. We look forward to seeing you next week. We're talking long context windows. We're talking RAG. We're talking with the folks at Gradient. Join us then, and we'll hear about how exactly they've extended the context window of Llama 3 so far, and they continue to do so. All right, so that's a wrap for today, everybody. Thank you so much for joining us. If you have any feedback, we'd love for you to share it with us. Don't forget before you leave as well to like, subscribe, ring that bell. And if you aren't yet in the Discord community, we'd love to have you. We're build, shipping, and sharing all the time as a community. And we really, really love new folks coming in, jumping in on projects. We've got some active ones going in the Discord. Tag me, tag Wiz if you need help navigating anything in there. And then if you're interested in joining the upcoming cohort of the AI Engineering Bootcamp, it kicks off May 28th in 2 weeks. And this will be probably the last cohort until about October. We've got some interesting stuff in the works that we're excited to release and announce soon. To check out all of our events, we've got the awesome AIM Index to start learning on your own. And until next time, we're going to keep building, shipping, and sharing. And we hope to see you do the same. Remember to tag us on LinkedIn and on social media. We look forward to seeing you guys next time, live on YouTube. Have a great week. Bye, everybody. See ya.